There are two types of subnetting we're going to learn in this course: fixed length subnet mask subnetting and variable length subnet mask subnetting. First, we'll talk about fixed length. Fixed length means that every subnet in your network will have the same mask. In the example from our previous lessons, whether we use fixed length or variable length subnetting, we will end up having the same mask for each of these three networks. Let me explain this example real quick. So we'll look at the first subnet. What's going on with my cursor? Here it is. Okay, so let's look at the first subnet, 10.0.0.0/27. So we have 15 laptops in this subnet. That means we need 15 different IP addresses to be assigned to our laptops. We need one more address to be assigned to our router interface. But we need two additional IP addresses for the network ID or the network IP address, and the second one for our broadcast IP address. That means in total, we need 18 different IP addresses per subnet. So each of these networks, each of these subnets needs at least 18 different IP addresses. If we use /27, that means we'll get 32 IP addresses per subnet. How did I get that number? Well, /27 means that the first 27 bits represent the network portion of the IP address, and then the remaining bits, which is 5, represent the host portion of the IP address. So 2 to the power of 5 is 32, which means that we can have 32 different combinations to be used as the host part of the IP address. Let's go to our next example. So here we have 3 smaller networks and 1 larger network. Of course, in all of these examples, the cloud that represents the internet is just going to be ignored. It's just there, and it could be any network. Let's start by counting the number of IP addresses we need per subnet. So we'll start from the largest network on the left. We need 8 IP addresses for 8 laptops, plus 1 IP address for the router interface, plus 2 IP addresses for the network ID and broadcast. In total, that's 11 IP addresses for the largest network. For the other 3 networks, we need 2 IP addresses for the 2 laptops, plus 1 IP address for the router interface, plus 2 IP addresses for network ID and broadcast. In total, that's 5 IP addresses for all of these networks. So this is our request. Create 4 subnets where 3 subnets should have 5 IP addresses each and 1 subnet that needs 11 IP addresses. And here I'm going to give you the solution right away, and then I'll walk you through that solution. The first thing you should notice is that each of these 4 networks that are different have the same mask. Okay, so how did we get here? First, I'm going to mark all the subnets and then populate the number of hosts. We're going to begin from the largest network, which needs 11 IP addresses, and then we're going to talk about the other 3 networks that need 5 IP addresses each. The next thing to be determined is the mask. So in fixed length subnetting, all of the subnets are going to have the same mask, and the masks for all of the subnets is determined by the largest network. So we just need to make sure that the largest network has enough different IP addresses to cover all of its hosts. For 11 addresses, we're going to need 4 bits. 2 to the power of 4 is 16. If we used 3 bits, that wouldn't be enough. 2 to the power of 3 is 8. So that's not enough for our largest subnet. If we were to use 5 bits, that's too much. That's wasting IP addresses because that's 2 to the power of 5, that's 32. That's 32 different IP addresses. We need 11, and we can get 11 by using 4 bits. So that's what we're going to do. Mask/28 is perfect for us because that means we'll use 28 bits for the network portion and the remaining 4 bits for the host portion. Again, 4 bits is enough because 2 to the power of 4 is 16. Now we'll just copy that into all the other subnets. Since this is fixed length, all of the subnets have the same mask. Our remaining fields are going to be network ID, which is the network IP address. And then the other or the last column is going to be range of useful addresses. So the network ID we're going to begin with is 192.168.1.0. Range of useful IP addresses will begin at 192.168.1.1. And the last useful address is going to be 192.168.1.14. 192.168.1.15 is going to be our broadcast address that we can't allocate to a host or a router interface. So the next network ID, the network ID for our second subnet is going to be 192.168.1.16. And don't worry if you're not sure how I got here. I'm going to explain this when we go through our more complex examples later. But for now, since these are very small subnets, you can see it for yourself by using simple math. So 2 to the power of 4 is 16, as we've said at the beginning. And here we have actually used exactly 15 IP addresses, or exactly 16 IP addresses counting the 0. So it's the 0th IP address, and then the other 15 are going to be 14 useful IP addresses, and the 15 is going to be broadcast. So the next IP address is 192.168.1.16, and we're going to use that as the network ID for our second subnet. Range of useful IP addresses in the second subnet is going to be the next 16 IP addresses as in the previous example, from 192.168.1.17 to 30. And then 31 will be the broadcast IP address for the second subnet. And then the network ID for the third subnet is going to be 192.168.1.32. And then again, we're going to use the next 16 IP addresses in that subnet, where 192.168.1.47 is going to be broadcast, and then 192.168.1.48 is going to be the network ID of the fourth subnet. And then the range of useful IP addresses for that subnet will be from 192.168.1.49 to 192.168.1.62. And the broadcast IP address there is going to be 192.168.1.63. And if in this example we had a fifth subnet, then the network ID for that subnet would be 192.168.1.50. So as you can assume, this is very, very basic. In the following lessons, we'll go through more complex examples. So just keep going and you'll be a pro very, very soon.